Okay, so that was all about convolutional neural networks. Next, we will jump into how we actually train these models. And before we do that, any questions you have? Okay, a question from Vijay. Number of channels are not getting changed at the second and third fully connected layers from the last. Instead of two fully connected layers, one can be used. Yeah, so again, that's just a design choice. I mean, two fully connected layers. I think you're talking about LXNet. So two fully connected layers were used. It's just a design choice, and it's just like we wanted more parameters to be learned, and the more parameters you have, it's kind of like more learning capability, right? So of course you can just use one fully connected layer as well. It will be just like less parameters. For example, you will have I think 16 million less parameters if you don't use FC7, but then you have like less learning capability as well, which might affect final performance. But I didn't get the first part where you're saying number of channels are not getting changed. So when you are at fully connected layers, you don't have the concept of number of channels, right? It's just like a flattened feature vector, which is being connected to the next layer. And all the values in that flattened feature vector are actually used to find the value in the next layer, because you do that linear combination of all of those, right? Using the weights which are being learned. So maybe you want to elaborate on that, Vijay? What do you mean by number of channels?
Yeah, Professor. 4096 are there, right? Yeah, the flattened
Yeah, so
values.
that's number of neurons.
Okay.
That's the number of neurons you have in FC6.
Okay. Yeah. Got it.
SSX is a fully connected layer. Is that it, Dr. Rawat?
Yes, yes.
Okay. Well, I don't understand what does the six mean? FC6, 7, and 8. Like, is it like the number?
Yeah, it's just like layer number. I mean, you can have anything, right? These are just names. So six, because it's the sixth layer, right? This is conf5, so fifth layer. Then there's the sixth layer, seventh and eighth. So in total, there are 8 layers.
Yep.
But I mean, it's just like, it's just naming convention. You could have used anything else. Okay, any other question before we move on to the next lecture?
I have a quick question. I noticed that we were using the normalizing layer after the max pooling, after the first two max pooling, but not the third. Why is that?
Yeah, again, that is a design choice. I mean, essentially, you can use after every layer. That's also fine. It's just like a design choice the authors had. They
Okay.
didn't want to use normalization after every first layer, right? And a lot of these things are actually estimated empirically. You try some runs and you see it's not working, and then you try to change it. And that's like one of the biggest limitation of deep learning. Most of it is like we don't know how exactly it's working. It's kind of a still not completely black box. A lot of it's known now, but still I think there is a lot to explore. And that's what like mathematicians hate. I showed you one of the slide, right? Okay. All right. Any last question before we jump to the next lecture? All right, good. So it's already 5:30. Okay. Any questions you have? I'll take those.
Professor, so like you said that with random initialization, we get random random loss. So like, why don't we initiate with a well-known fixed values if we are getting the random loss anyway, like random results anyway?
How will you do that? Like what kind of values?
like some kind of intuition that worked with the previous experiments or previous models rather than completely using random values.
Yeah, we do that actually. I mean, that's a good point, and that's like called fine tuning, and I think we'll come to that later. So as I said, training these networks require a lot of data, right? And for some of the problems, you might have a lot of data. For example, ImageNet, it has million of images, right? You can train a model from scratch, or by scratch, it's like randomly initialized. But you might have a different data set where you don't have a lot of samples. In that case, it will be very difficult to train. In that case, we do exactly what you're saying. We take like the initialize or the train weights on ImageNet, and we take that as a starting point. And then we continue the training process.
Okay.
Okay, so if there is no other question, we can end it here. And I will see you on Tuesday. So this Thursday, we won't have any lecture. Okay, thank you.